Started year 9, sorry about that. Alright, so don't worry if you haven't finished writing this down. Let me talk through this one first. Just listening, guys. So, we've been looking at direct proportion and a bit of ratios as well. And so what we want to understand year 9 is that since the graph of the equation which has direct proportionality, need your full attention here. Since the graph which has direct proportion, we know that it goes through the origin, we know it's a straight line. We can describe in terms of coordinate geometry, we know it has this equation here, y equals to kx. And I showed you up on the screen earlier that no matter what number I changed k to, it was always a straight line going through the origin. And so k, we can understand as the gradient of the graph, how steep something is, right? And what happens when that k value gets really high? Well, I get a really steep line, right? But it still goes to the origin. How are we going to use this to solve problems? Before I do that, I just need to introduce some notation. So K, we call the constant of proportionality. Okay, it's just a word that they give it. And this symbol here, it's not the same fish symbol that you saw before. This is saying that if you have y fish x, it's the same as y equals to kx. 2 minutes, 4 seconds. Alright.
How long did we take?
2 minutes, 4 seconds.
Oh, we had 2 minutes!
It's the same as y equals to kx, okay? So these two are the same thing. If you ever see these two, they mean the same thing.
Well, the K and the fish, that means they are like...
Okay, so... No. So this statement, this whole statement, is the same as this whole statement here, okay? That's what this is saying. They just have two notations for the same thing. Okay. Freya, can you read this out one for me?
For the following, find the content of proportionality and the rule of
Okay, thank you. So this is why it's important. This is why it's important to know your words. When they're asking you to find the constant of proportionality, all they're asking you to do is find k. Okay. So this is saying find k. How are we going to go about doing that? Well, they actually give us some information here. And so mathematics, all we're doing is we're given some things and we want to find out the things that we don't know from them. So I've been actually given some values. I've been given y equals to 12 and x equals to 3. And obviously I'm trying to find k, right? So how do I go about this? Well, since I've got this statement here, I know that y varies is directly proportional to x. So I can write that as y is equal to kx, okay? Whenever I see this, I can write this statement as well. They mean the same thing. Now, how does that actually help me? Well, it helps me because I've been given my x and y values, haven't I? What is my y value, Harry? 12, okay. And what is my x value as well? 3, right? So now I know that 12 is equal to k times 3, okay. And Lucas, can you remind me, when it says find the constant of proportionality, what are they actually asking me to do?
Find K.
Find k, right? And so all I've got here is just a linear equation. So I've got 12 is equal to k times 3. So how could I go about finding k now?
Divided by 3.
Yeah, so I think about the opposite multiplication. I divide both sides by 3. So I'll get 4 is equal to k, or k is equal to 4. Same thing. And that's not quite the end of the question because they also want me to find the rule linking that. And all that's asking for is for you to write that statement in this form here. So all we write down is y is equal to 4x. Okay? So that's the rule linking them
It's pretty
together.
simple, isn't it?
It is pretty simple. And just to check this actually works, when you substitute x as 3 here, you get 4 times 3, and that's the same as 12. Okay. So that's confirming that the answer you got as correct. Have a go at this one for me now.
Sir,
Yeah.
why do you have to do with fish and sailing?
Because they'll give it to you.
Yeah, but why?
I don't have a good reason, but it is notation.
They're just making it harder.
It's multiple ways to write the same thing. That's what it is. I'll get back to you in why. I will get back to you and find an answer. I don't know right now, but I'll try and find an answer. So, even though they use different letters here, you know, you can still apply this idea. So anytime you see A, this symbol, and B, Angus, can you tell me what can I write since they've given me this? What can I write? Say that again, sorry.
30 equals k times
Okay, before you even write that, what did I write here?
y equals k.
Yeah, so, yeah, but use the variables you can
A
do.
equals k equals a.
Perfect, right. A equals K. Always write that out so you know what you're actually doing. And then, as Angus did before, then you can substitute the values you're using. I always want you to write down, at least for the first time you're doing it, all the working you're doing, so you actually know what you're doing. Okay? Once you have that, you can substitute the values in. So, you've got 30 is equal to K times 5. And again, you're just trying to solve for K, so not too hard here. Divide both sides by 5. You'll get 6 is equal to K. But remember, the question that we're trying to do is we're trying to find the rule linking them together. Okay. Dan, can you help me out? Once I've found K, how can I find the rule linking the two variables together?
Let's see. You go. What do you mean? Like.
So I want something like this, but for this question.
Oh yeah. Y
Yeah.
equals
There is the same one there.
6x.
Okay. So just be careful what variables are we using here.
Fishy.
We're using
A.
A and B, right?
A equals 6b.
Yeah.
Why is
Perfect.
it easy? Oh, it took it hard.
Well done.
No, shut up, Lucas. It's not.
Any questions on that one?
Oh, I should write that.
Alright, so let's look at this next question here. Montana, can you read out just the start of this question for me?
The weight of 10 cents coins in a bag varies directly with the number of coins 10 coins weigh.
Should be weigh. How much did they weigh, Angus?
About 85.
About 85 grams. Not 85 kilos. 85 grams. Okay. So, when you does anyone work here?
Yeah.
Where do you work, Lucas?
Horse racing stable don't get paid those things.
Okay. Does anyone work somewhere and get paid? Yeah.
I don't know.
Scouts. Where do you work? Okay, yeah, so in a shop, right, when you, I don't know if you would be in your auntie's shop, but if you go to Woolworths, or, do you work at Woolworths? No. Do you work at
I
Woolworths?
work at a cafe.
A cafe, do they get rolls in the coins in the
Yes,
rolls?
yeah.
Yeah, right. Where do you work, Montana?
It's like an IGA.
Okay, yeah. So if you ever work at a big shop like Woolworths or Coles, when they get money, they don't just get them, like a massive box or a bag or something. When they print them from the Australian Mint, they actually stack them in these kind of rolls, right? They look like sausages.
Yeah.
Yeah.
My mum, she works at the bank.
Oh, really?
I
Yeah.
saw them and they have all.
Does she take some home, is that
No, they have all the stacks.
Yeah.
I can't refill it.
Okay, cool. So we get all of these stacks of coins. Coming back, we get all these stacks of coins, but it's really interesting to look at the relationship between the number of coins and the weight that we have. So Angus kindly weighed for me the coins and how heavy they are. So we know that 10 coins weigh 85 grams. And the first question is, find the relationship between W, which is my weight, and N, the number of coins I have. Okay? So I know, for example, when I have N equals to 10, my W value, that's equal to 85. So all we're doing now is we're taking a problem like this and we're giving it some context, we're giving it some purpose, okay? So what do I want to do next? Well, I know it varies directly because they tell me that in the question. That's really important. Because I can do that, then I know that I have W equals to Kn, right? Because that's the equation that I was looking before. You know? Who else? When you're ready. So over here now, I can substitute those values in. I've got 85 is equal to K times 10. And then to find the constant proportionality, I can just solve for K now. I divide both sides by 10. I get K is equal to 8.5. K is equal to 8.5. This is question A. Now, when they're asking me to find the relationship, they're really asking me to find the link, right? Find the link. So then I need to realize, okay, I know that I have this equation here, so I can rewrite this as W is equal to 8.5n. Any questions so far? Now that you have the constant of proportionality, this is actually really powerful because you have a link between the weight and the number of coins, right? When they ask you something like this now, how much will 57 coins weigh? Well, you know that that's asking, okay, I've got 57 coins. That means my n value, that's just 57, right? So n is equal to 57. And so all I need to do is substitute into this formula that I've created myself, we've developed, n is equal to 57. So I just replace n with 57 in my equation.
I had that first one, I was like, oh, maybe it's not 8.
Just 480.
No, Alice.
What do you get when you punch that in?
484.5.
Well, that's decently heavy. 484 point what, sir? 0.5 grams. Have a go at the next two for me now. Yeah.
Is that
W
W?
equals 8.5n for question 2.
Which one, sorry?
W equals 8.5n. Is that the start of question 2e?
No, that's the end of question A. That's the answer.
We have Nori. She's really good.
They're a family relationship.
See ya.
Yeah, just for you guys.
Wait, so...
I literally just got the textbook and added some lines to it. Yeah. All good?
How many lines wait
How much will $12 worth of coins weigh?
Oh, 28.
Does anyone know?
Yeah, I did it. Now can I go? Can I just stop?
Can you go? What's up, shit?
Why? I thought that was a cruel joke. That's not fun. Matt, leave the sheet. I'll give you a high five.
What's up?
What's up?
Yeah.